Hello everyone. So, in last class we considered second order PD and seen the mathematical characteristic of those equations. Also, today we will consider system of first order PDs and we will find the mathematical characteristics of those equations. So, first let us consider this system of equations. So, we are considering this a set of two first order PDs, okay, first order PDs. So, we can write these equations like del u by del t plus a 1 del u by del x plus a 2 del v by del x plus a 3 del u by del y plus a 4 del v by del y plus C 1 is equal to 0. So, this is one first order PD and another PD will write as del b by del t plus b 1 del u by del x plus b 2 del v by del x plus b 3 del u by del y plus b 4 del v by del y plus C 2 is equal to 0. So, we have considered two sets of first order PDs. In general, we can write this equation as del u by del t plus matrix A del u by del x plus B matrix del u by del y plus C is equal to 0, where you have u is equal to this vector u v. Okay. So, what is your A? So, A you can write as, you can see these are the coefficients. So, from here you can see that this will be A 1, A 2, B 1, B 2. Okay. And similarly, you can see that your B will be A 3, A 4, B 3, B 4 and C will be your vector C will be C 1, C 2. Okay. So, we have represented these two partial differential equations, first order partial differential equation in general manner. So, where u is represented by the vector u v and correspondingly A B matrix and C vector we have represented. Now, we will classify this equation as if the eigenvalues of the matrix A are all real and distinct, the set of equations is classified as hyperbolic in T and X. Okay. So, we have considered the A matrix, and if the eigenvalues of this matrix are real and distinct, then the equations will be classified as hyperbolic in T and X. And similarly, we are not writing, but similarly you can see the eigenvalues of B are real and distinct, then the equations will be hyperbolic in nature in T and Y. Okay. So, that we are not writing, but similarly you can say that. Now, for complex eigenvalues of A, the system of equations is elliptic. Okay. So, if you have a complex eigenvalues, okay, then it will be elliptic in T and x. Similarly, for the B matrix, if the eigenvalues are complex, then the equations will be elliptic in T and y. Finally, the eigenvalues are real and there is less than n real characteristics where n is number of PDs, then equations, then the set of equations is classified as parabolic. Okay. So, if you have a system of equations and if you can write in this form whatever we have written in this equation, then depending on the eigenvalues of A and B matrix, you can say whether the equations are hyperbolic, elliptic or parabolic, and is parabolic in T and x. Similarly, for if eigenvalues of A, okay, eigenvalues of A, and similarly for eigenvalues of B for real and there is less than n number of n real characteristics, then the set of equations will be classified as parabolic in T and y. Now, let us consider another set of partial differential equations, first order partial differential equations. So, the system of equations has the following form for steady state, let us say, then we can write as A del u by del x plus B del u by del y plus C is equal to 0. Then the set of equations is classified according to the sign of H, okay, where H is equal to R square by 4 PQ and P is just determinant of A, okay, Q is determinant of B and R is your for this set of equations A1, A4, B1, B4 plus A3, B3, A2, B2. Okay. So, where A is your A1, A2, B1, B2 and B is your A3, A4, B3, B4. Okay. So, depending on the value of H, where H is equal to R square minus 4 PQ and P, Q and R are given as this, and if the value of H, so the set of first order PDs is hyperbolic for H greater than 0, okay. It is parabolic for H is equal to 0 and elliptic for h less than 0. Okay. So, this is another way to find the mathematical characteristic of a system of PDEs. The next we will learn another method, okay, which is based on the characteristic. So, you need to find the characteristic, normal characteristic, then depending on the characteristics values you can find the mathematical character of those equations. Now, we have already learned what is characteristics. So, characteristics represent a family of lines across which the properties are continuous, whereas there may be discontinuity in their derivatives. Okay. Now, if we define S, which is the characteristic surface, then we will find the normal to that characteristic surface. So, let us say that S is your characteristic surfaces and characteristic surfaces, and normal to these surfaces denoted by n, where n is equal to n x I plus n y j, okay, for 2D Cartesian system. Okay. So, if the system surface is defined as S, then the normal we are defining n as n x I plus n y j for a 2D Cartesian system. So, now based on this normal we can find the mathematical characteristics. So, if the characteristic normal are all real, then the system is classified as hyperbolic. Okay. If they are complex, then the system is elliptic, and the system is classified as parabolic if there is less than n real characteristics or repeated characteristics, where n is the number of PDs in the system. Okay. So, now this characteristics of this normal if you find. So, if these are real and distinct, then it will be hyperbolic. If it is complex, then it is elliptic, and if it is real and repeated, then it is called parabolic. So, now let us consider these set of equations. Okay. Consider the following set of equations. Okay. A1 del u by del x plus b A2 del v by del x plus A3 del u by del y plus a4 del v by del y is equal to 0, and b1 is del u by del x plus b2 del v by del x plus b3 del u by del y plus b4 del v by del y is equal to 0. Okay. So, these are the set of two first order PDEs. Now, let us write in general form A del u by del x plus b del u by del y is equal to 0, where you have u is equal to vector u v, and obviously a and b will be a1 a2 b1 b2 and b is a3 a4 b3 b4. Okay. Okay. So, now the characteristic direction for the system may be obtained or is obtained if determinant t is equal to 0, where t is a n x plus b n y. So, a b we know. So, these are the matrix. Now, t is defined as a n x plus b n y. So, t you can write as a 1 n x. So, you can see a is nothing but this. So, a 1 n x plus a 3 n y. Okay. Then b 1 n x plus b 3 n y, a 2 n x plus a 4 n y, and b 2 n x plus b 4 n y. Okay. So, this is your T matrix, and if you find the determinant mod T, you are going to get a 3 b 4 minus b 3 a 4 n y square plus a 1 b 2 minus a 2 b 1 n x square plus a 1 b 4 plus a 3 b 2 minus a 3 b 3 minus b 1 a 4 n x n y is equal to 0. So, determinant should be 0. So, from here you can write as q n y by n x square. So, if you rearrange it, you will be able to write in this form n y by n x plus p is equal to 0, where q is equal to a 3 b 4 minus b 3 a 4, then r is a 1 b 4 plus a 3 b 2 minus a 2 b 3 plus a 1 minus b 1 a 4, okay, and p is your a 1 b 2 minus a 2 b 1. Okay. So, now you can see this is a quadratic equation. From here you can find n y by n x. Okay. It will be minus r plus minus root r square minus 4 p q by twice q, where we have defined h as minus r plus minus root h divided by twice q. Okay. So, now you find the n y by n x, okay, and you see whether these are real and distinct characteristics, then it is hyperbolic, and if it is complex, then it is elliptic, and if it is real and repeated, then it will be parabolic. So, here you can see that when this n y by n x will be complex or real and distinct, you can see from the value of h. Okay, and already we have defined that if h is greater than 0, then you have a hyperbolic Okay. If h is 0, then it is parabolic, and if h less than 0, then you can see it will be h, if it is h less than 0, then it will be complex. So, it will be elliptic. Okay. So, now today we have learned three different ways to find the mathematical characteristic of system of PDEs. Now, we will consider a different set of PDEs and we will find the mathematical characteristic of those equations. So, first let us consider Cauchy-Riemann equation. Cauchy-Riemann equation. Okay, so, we consider two set of PDEs, one is del u by del x plus del b by del y is equal to 0 and del b by del x minus del u by del y is equal to 0. So, these set of equations are known as Cauchy-Riemann equations, and essentially this boils down to Laplace equation. Okay. So, you can see here del u by del x. So, if you take in the first equation, if you take the derivative with respect to x, then you will get del 2 u by del x square plus del 2 v by del x del y is equal to 0, and if you take the second equation, okay, the derivative with respect to y, then you will get del 2 v by del 2 del x del y minus del 2 u by del y square is equal to 0, and now if you substitute del 2 v del x del y is equal to del 2 by del y square, then from here you will get del 2 u by del x square plus del 2 u by del y square is equal to 0. Okay. So, from here del 2 v by del x del y is equal to del 2 u by del y square. So, if you substitute it, you are going to get a Laplace equation. Okay. Now, let us say that these set of equations we have, how to find the mathematical characteristics of these set of PDEs. So, we will consider these three different methods what we discussed, and we will find the mathematical characteristic of this set of first order PDEs. So, whatever first approach whatever we have learned, okay, let us see how to find. Okay, so, we have to write in terms of del u by del x plus b del u by del y is equal to 0. Okay. So, now if you write in this way, then what will be your b? Okay. So, now del u by del x, b del u by del y. So, u is your u b, this is the vector. So, if you put it del u by del b, then what will be your b? B will be, you can see from here. So, first equation you are getting, you should get del u by del x plus del b by del y, right. So, if you want to get del b by del y, then you have to see first one will be 0 and this will be 1. Okay. So, it will be 0 1, and now second equation if you want to get, then you will get del b by del x. So, here you should get minus del u by del y. So, it will be minus 1, okay, it will be minus 1 and it will be 0. Okay. So, this is the b. So, you need to find the b matrix from here. So, from here you can see that if you put this, then you are going to get b as this. So, now for we have to find the eigenvalues. So, it will you can find as b minus lambda is determinant should be 0. So, that means minus lambda. So, b is this one. So, it will be 1 minus lambda should be 0. So, that means lambda square plus 1 should be 0. So, lambda should be plus minus I. Okay. So, now we can see that the eigenvalues are complex. So, obviously, the set of equations is elliptic in nature. So, elliptic in nature. Okay. The second method if you use, then you can see how you can find. Okay. So, second method or second approach whatever you have learned today. So, if you use, then you can write this equation in this way: A del u by del x plus B del u by del y should be 0, okay, where u is u v vector. So, you can find what is A. Okay. So, A will be your 1 0 0 1. So, you put here A, then you can find that whether you are going to get the set of equations whatever we have written del u by del x plus del b by del y is 0 and del b by del x minus del u by del y. So, from here you find the matrix A and B. Okay. So, B will be your 0 1 and minus 1 0. Okay. So, now find P, Q and R. So, P is your determinant A which is 1, Q is determinant B. So, it will be also 1 and R. Now, with this you can write all these coefficients you have. So, it will be 1 1 0 0 plus 0 0 minus 1 1. Okay. So, this will give you 0. Okay, you find the determinant and add it, it will be 0. So, now you can find H is r square minus 4 p q and r square is 0 minus 4 p is 1 q is 1. So, it is minus 4. So, the value of H is less than 0. So, obviously, it is elliptic in nature. So, as H is less than 0, the system is classified as elliptic. Okay. Now, another method we will use, that is your characteristics. We will find the normal characteristics. So, third approach. Okay. So, now you find A B you know. So, T will be A n x plus B n y. Okay. So, from here you can find that it will be n x 0 0 n x, okay, plus 0 n y and minus n y 0 and you will get as n x n y minus n y n x. Okay. After addition you will get this. Now, you find the determinant of t. So, it will be n x square plus n y square. Okay. So, and it should be 0. So, you can see that n y by n x whole square plus 1 should be 0 and n y by n x should be plus minus I. So, you can see the characteristics are complex. So, obviously, the system of equations will be elliptic. So, that means the characteristic normals are complex. So, the system is elliptic. Okay. So, you can see that we have considered Cauchy-Riemann equation and we have used 3 different methods which we learned today and applied to find the mathematical characteristic of this Cauchy-Riemann equation, and we found that this is elliptic in nature. And also you can see that if you convert it to second order PD, then we are getting one Laplace equation, and in last class we have shown that Laplace equation is elliptic in nature. Now, let us consider these 2 sets of PDs. So, consider the following first order PDs. Okay. So, this will write as del V by del T minus C del omega by del x, where C is the wave speed, and del omega by del T minus C del V by del x is equal to 0. Okay. So, these equations actually if you convert it into second order PD, it will become second order wave equations. Okay. You can see del B by del T. So, this wave equation you can write second order wave equation, second order wave equation. So, you will get as del 2 u by del t square is equal to c square del 2 u by del x square, where V is del u by del t and W is C del u by del x. So, if you use this transformation, you are going to get the second order wave equation, and we know that second order wave equations wave equation is hyperbolic in nature, but now we have two sets of equations. So, we will find the mathematical characteristic of these PDs. So, first we will use this first approach whatever we have learned. So, you have to write this equation in this form del u by del t plus a del u by del x is equal to 0. So, where u is the vector u v and a is you can find from this set of equations, a will be 0 minus c 0. Okay. So, c is the wave speed. So, now the eigenvalues you can find. Okay. So, determinant of a minus lambda I should be 0. Okay. So, it will be minus lambda minus c minus lambda should be 0. So, you will get lambda square minus c square is equal to 0. So, lambda is equal to plus minus c. So, you can see the eigenvalues are real and distinct. So, the set of these PDs is hyperbolic in nature. So, the eigenvalues are real and distinct. So, the system of equation is hyperbolic. Now, we will use the second method. Okay. So, we will use the second approach. So, whatever we have learned. So, our equation is del b by del t minus c del w by del x is equal to 0 and del w by del t minus c del v by del x is equal to 0. So, we need to write this equation in this form to use the second approach del u by del t plus b del u by del x. So, we are learning just these three different methods. So, we are applying these three different methods to find the mathematical characteristic of these set of PDs. Okay. So, this is your 0. So, u is in this case V w, sorry. So, here it is not u, it is be V w. Okay. So, make this correction. Okay. So, I wrote u v, it is only we have V and W. So, u will be V and W. Okay. So, this correction you please make. So, V W and you have A. Okay, you find A will be 1 0 0 1 and B will be 0 minus C 0. Okay. So, this is your, so P you can find determinant A 1, Q will be determinant B. So, determinant B will be minus C square and R will be 1 minus C 0 0 plus 0 0. This you just find from these coefficients. Okay. So, I am not going to write this, but you have to find. Okay. Then it will be 0. So, H will be R square minus 4 P Q. So, it will be 4 C square also, which is greater than 0. So, it is hyperbolic. Okay. Now, let us use the characteristics normal characteristic method. So, that is your third approach. Okay. So, you find the T. So, it will be T is your A n x plus B n y. So, if you A B if you add it, you will get n x minus c n y, this is minus c n y, it is n x. Okay. So, determinant t will be n x squared minus c squared n y squared is equal to 0. So, you will get n a y by n x is equal to plus minus 1 by c. Okay. So, the characteristics are real and distinct. So, obviously, the set of equations is hyperbolic. The characteristic normals are real. So, the system is classified as hyperbolic. Okay. So, next we will consider another set of PDEs. So, we will write this system of PDEs like del u by del t minus alpha del v by del x is equal to 0 and del u by del x minus v is equal to 0. Okay. So, this equation actually represent, if you convert it into second order PD, then you will get unsteady one dimensional heat diffusion equation, 1D unsteady heat conduction equation. So, it is del u by del t is equal to alpha del 2 u by del x square. Okay. So, now alpha is the thermal diffusivity. So, now let V is equal to del u by del x. Okay. If V is del u by del x, then you can see del u by del t. Okay. So, it is alpha del 2 u by del x square. So, you can write alpha del V by del x. Okay. Alpha del V by del x, alpha del V by del x. Okay. So, that means you are getting one equation is this, which is we have written del u by del x minus V is equal to 0, another equation we have written del u by del t minus alpha del V by del x is 0. Okay. So, that means this one dimensional unsteady heat conduction equation actually we have written in two set of PDEs. Okay. So, now considering these two sets of PDEs, now let us find the use the second approach. Okay, second approach. So, in the second approach you write A del u by del x plus B del u by del t is equal to C, where u is equal to u v, A is equal to 0 minus alpha 1 0 and B is 1 0 0 0, okay, and C will be the vector 0 v. Okay. So, you just find from these two equations you can find this matrix A B C, and now P will be just determinant A. So, you will get alpha, Q will be determinant B. So, it will be 0, you can see from here, and R will be, so 0 0 1 0 plus 1 minus alpha 0 0 and it will be 0. So, H will be R square minus 4 P Q, okay, R square minus 4 Q. So, R is 0, okay, and minus 4 into alpha into 0. So, that means it is 0. Okay. So, if R is 0, then obviously the set of equations is parabolic. So, it is parabolic in nature. Similarly, if you use the third approach, okay, so you find the T. Okay, so, T will be your A n x plus B n t. Okay. So, n t I am writing because it is a time derivative, that is why, and if you put it. So, a and b you put it, you finally will get n t minus alpha n x, n x and 0. Okay. And determinant t if you find, then it will be alpha n x square is equal to 0, that means n x by n t is 0. So, you can see the characteristic you have. So, n x by n t. So, this is n x by n t is 0. So, it is real and you have only two equations, but you have one characteristic, that means less than n, where n is the number of PDs. So, here n is equal to 2 because you have two PDs. Okay. You have two PDs, but you are getting one characteristic, okay, 0, n x by n t is equal to 0. So, there is only one real characteristic. So, the system of PDs is parabolic. Okay. And also you can see that you have one dimensional unsteady heat conduction equation and it is a second order PD, and we have shown in last class that this is also parabolic in nature. So, today we considered a set of set of first order PDs, and we learnt three approaches, and first approach we have found the eigenvalues, and from the eigenvalues we have determined whether the system of PDs are parabolic, elliptic or hyperbolic. Then we have considered these eigenvalues. If these are real and distinct, then it will be hyperbolic. If it is complex, then it is elliptic, and if you have eigenvalues real and less than n eigenvalues, where n is the number of PDs, then it is parabolic. In second approach also we have found the R. So, where we have found the H, where H is equal to R square minus 4 p q, and depending on the value of H. So, if H is greater than 0, then we have found that it is hyperbolic. If it is less than 0, then it is elliptic, and if it is 0, then it is parabolic. And in the last approach we have found the normal characteristics, and if normal characteristics are real and distinct, then it is hyperbolic. If normal characteristics are real and repeated, then it is parabolic, and if normal characteristics are complex, then it is elliptic in nature. Thank you.